Hi, good evening or good afternoon, and hopefully that it's not a good morning for sure. That I'm trying to that continue that what we had been doing yesterday, because that yesterday we were running out of time and then we couldn't finish chapter 5. This is the we are in the middle of that going through the or explaining all the material of chapter 5. I think I did all the way up to chapter in that particular chapter that all the way up to like four sections. Okay, so we built up that in chapter 5 that we built up some kind of a discussion for that how to build up some certain model to explain one variable through another variable. In that discussion that we very clearly mentioned that in the very beginning that we're not going to include two variables. We're going to go ahead and look for one variable, that particular variable, the outcome variable or the y variable. uh, Y variable mainly quantitative variable, okay, quantitative variable, okay. This quantitative variable that been explained by only by its average, its own average, not by another explanatory variable, its own average. In order to get this done, we were looking for some kind of a mathematical structure called the model. That model can be utilized for that similar kind of any scenario. Okay, so that when they have some kind of a data set that coming from like a same kind of a scenario, we can utilize that model. Okay, so in the very beginning, as I mentioned earlier, that even yesterday I mentioned that we have only one variable. It's been explained by its own mean. Mean has been utilized in order to explain that one, because we thought when you talk build up the model would be that an estimate for that real data. How real data can be explained through a model? When you have that, it's an estimate, okay? But the real data gonna be the perfect data. Those are the true data. But when you have the model plus some kind of a error incurred during this estimation procedure, that error has to be taken into account, because of very clearly we know that in statistics or data analytics we are trying to minimize the error. That means we are trying to get as much the estimate or the model as close to the true values. Okay, that's our purpose. In order to do that one, when we are not having any that many models are available, we might gonna go to the best model that fitting into the given data set. Okay, so based on that mathematical approaches and everything, that they came up with some kind of a model and say, hey, data equals the model plus the error. We saw that one. Now we are in the middle of that explaining how it's gonna work. Okay, so I'm gonna go ahead and then get into 5.4 where that I stopped yesterday. So what I'm gonna do, I'm gonna go ahead and share my other screen. Okay, I'm gonna go ahead and share this one. Okay, yeah, in 5.4, generating prediction from the empty model. We can remember we were talking about the empty model because that it is how that has been done in this scenario. This scenario means like the way that we had done in the very beginning. We were using the empty model in which we are not using any of the explanatory variable, just that y variable or response variable only. Okay, this is what we had in the beginning. Okay. Let's see. Okay. Okay, that was. See, we were talking about we have a data. See, data. We were talking about the empty model, empty or null model. Okay, in which data being modeled by the model plus other stuff. means we have a data equals to null model, null or empty model, plus other stuff means we can say error if you want in the population version. That means this is y, this means this is y bar, this means this epsilon. Epsilon means that either residual or error, doesn't matter, or deviation. That means if you want the error, that means epsilon, this is called epsilon. Okay, that means the error. Okay, epsilon is nothing but y minus y bar or y bar minus y, doesn't matter either way. Okay, either way that you're gonna see that by looking at this one. If you have a value that above y, then you get positive value. If you have a y value below y bar, then you're gonna have a negative y value. Anyhow, those deviations will be added together and you're going to end up with 0. Okay, we saw that one. So in R, how could you going to do that one? R, how could you going to do that one? You're going to go to LM. LM means linear model. And then you're going to put the y first, whatever the y, tilde, then put null, because you don't have to say anything for the here. See, this one, you don't have to say y bar. You put this guy, see, you put this guy, tilde, you put this guy, which is null, see, and then you're going to call the data. See, that would give you that intercept. Intercept means that we're going to give the intercept means nothing but y bar. That means sample mean. Sample mean, no average. Okay, average. So this one, then we saw that one. Later on, what we did was for each and every data point, we calculated the error. Each and every data point, you can calculate the error. How could you gonna do the error? Sometimes we're gonna, how do you calculate the error? Error can be calculated in two ways. See? Error, or I'm gonna call the residual. Residual can be calculated in two ways. How? By true value, see, real value, see, true value or the estimated value, okay, estimated value, or we call the predicted value, see, minus true value, the real value. Or you can write the other way around, true value minus predicted value. See, that's how we did that. Or you use the, okay, this first method, then the second method, error, you used to get this one, res of what? Res of that linear model. See, res of linear model. That would give you the residual. And then you can assign that one to something. When you write the code, you can assign that one to something. Okay. Two ways we got this done. So this here we discuss about that as if that if we hadn't collected data, so the model have predicted this long time. See what our model have predicted about the thumb length. Our thumb length. See, thought if you don't have a data, if you haven't collected data, but still you have that model gonna be fitting into the data. Okay, we already have a model. Okay. We already have a model coming from that population, which has been set up for the population that can be even utilized even for the sample. If you haven't collected data, what our model would have predicted, see, what would our model have predicted? This thumb length, see, thumb length to be, see, what our model would have predicted thumb length to be, see. That's what we call the prediction. See, that's the prediction. Prediction is nothing but what would our model have predicted this thumb length to be. See that it's gonna predict it's every thumb length has to be the same as its own average. See? That's the prediction value. See? 62 because that's the average. That's the predicted value. See? That's the predicted value for each and every data point. That's the predicted value. See? You saw that thing at the side. That's the predicted value. See here, this is the predicted value. See, that's the predicted value. This is see, this is see, predicted value. Predicted value or estimated value for each and every data point. See, in every data point. So we found the difference between those. See, then we find the prediction, and then I put it back into my data set. I'm using the Tiny Fingers data set. I'm going to call that new one called the predicted. Then I'm going to use the prediction. Predicted means like a predict and then put it back into the original data set. See this one. The tiny empty model is this one. Okay, you know that tiny empty model means tiny empty model is nothing but, okay, if you cannot remember, tiny empty model is I assign that one to my, when I run the model, then I say that y would be what? Thumb, no? Is that the thumb? It's our variable. Our variable should be, what is the variable? Yeah, thumb. Okay, thumb would be our variable. So it's going to go to thumb tilde, then null. The data, like tiny fingers, see? Tiny fingers. The tiny fingers, and then you go to that one and then to run the prediction on that one and see that if the data has not been collected, what would our model explain that each and every data points to be. Okay, see? Predicted this thumb length to be. Okay, so then you're gonna go ahead and run that whole data set. See? You've got that tiny fingers, you've got the thumb length, and there is a tiny empty model, and go to and prediction, do that one, and then it's called the predicted, and you put it over here. See, that's what we see here. Now they were asking, look at the printout of the thumb length and predicted thumb length. Thumb length and predicted thumb length. It's a predicted thumb length. Okay, that means the average. Average can be considered as for each and every one. See, which two student thumb lengths are close to the average, 61 and 63. Which one is below average? This one above average. See, the 1 unit below average, 1 unit above average. Okay, student 3 and 4 going to be very close to that. As I mentioned over here, error would be something y minus y bar or data minus mean. How do you get that one? You have a data. See, or either way. Okay, either way, data minus. See, data means the model. See, y minus y bar or y bar minus y. Y minus y bar. See, y minus y bar. They take that one y minus y bar for your convenience. See, y minus y bar. See, so y would be your value, which is data. Data means y. See, it's the same thing. That's the same thing. See, see here. We talk about the same thing. See? That's the same thing. See? It's the same thing. Estimated value is y bar minus y or y minus y bar. So they stick to this one, y minus y bar. Okay, y minus y bar. See, y first and y bar. See, this is thumb. This is my y. Predicted means y bar. See, that would give you the some lengths. You know that some lengths are below. Then if you subtract this minus that, difference is negative, then positive. If you add all these together, it can be 0. And on the other hand, they say that to modify this to save residual from the time to empty model, and then you can use what? Residuals. You can find the residual. See, you can say that's the residual. This is the residual. It's nothing but this residual. The residual has been put it back into that tiny fingers data. Okay, so you can have a new column called residual. That difference has been assigned to residual. Where? In the tiny fingers data. See, then you have another column. See, that's what they would. Instead of that one, you can calculate the receipt from the straight from the model. Right from when you run the regression model, or run that null model, you can get the value and then find the receipt. See, you still get the same answer. See, that's how they say. Now you call that one a different name. You can call the easy one. Easy one, how do you get that one? In this way. It's a second way of getting. See? As I mentioned here, see? Now you're going to, rather than take the difference between the estimated or predicted value and true value or real value, or y and y bar, or you can straight go to the residual of the linear model. See? That's what we are doing. And then we run that one. See? They have another one. See? It's a predicted value. It's a residual value. If you want to keep the both of them, then you make sure that you have to keep this guy there as well. See? You have to keep this residual, the way that how you got the residual by taking the difference between predicted value and the estimated, predicted value and true value of the thumb length. See? Thumb length, real value, and predicted value. That difference would give you within that given data set residual, and then later on you use the easy way to get that one. Okay, but you still get the same thing. See? Easy residual and residual. If you want the residual first, you can put the easy residual second. See? First easy residual. If you want residual one first, I'm gonna get this one and put it here. Predicted easy residual. Easy residual. I'm sorry that we need the residual first. Why doesn't come? Tiny fingers residual. Residual. But this is not running. So, let me see. I run here. Okay, tiny fingers residual means this one, and the other one is called the easy residual. Okay, and you're going to run this one. Okay, and paste. Don't need this one. Then see what's going to happen. See, residual and easy residual. That's the same value. Okay, talking about it. Then you're going to draw that histogram for this guy, real value, predicted value, residual, easy residual or residual. These three. For these three columns, you're going to draw the histogram. You know how to draw histogram. See? What is the different about the distribution? The distribution of the data and the residual have the same shape. Look at that. This guy and this guy, or this guy has the same shape. See, you saw shapes. Same shapes. but the number on the x-axis differ across the two distributions. Number on the x-axis, see, number on the x-axis differ across the two distributions. Okay, the distribution of the thumb is centered at the mean. This is centered at its mean, which is 62. Centered at the 62. Below 62, there are 3 data points: 56, 60, 61. Below 62. Above 62, there are 3 data points: 63, 64, 68. See, the mean is over here. Here, not like that. On the error that distribution, whereas the distribution of residual centered at 0. Centered at 0. It's been, see, centered at 0. And there are 0 would be your average. If you're going to add these and divide it by 6, that would be 0. You know that one. That average is always 0. If you add all these and divided by 0 would give divided by number of observation, which is 6. 0 divided by 6 will give you 0. See, that's how you get the 0 for its average. Average of the residual would be 0. And then all the 3 data points means not the original data, I mean the residual data points, which are -6, -2, -1, 1, 2, 6, are equally distributed by 3, 3 above and below. See, like that. See, that's what they've explained. See? Now print out favorite steps for the thumb and the residual for the tiny fingers data frame. See, favorite statistics. Okay. Get the fav stat for thumb, get the fav stat for residual. Okay. Okay, fav stat. Fav, okay. Favorite stats. So I'm gonna say thumb coming from data equals tiny fingers. Okay. In the same way, I'm gonna find the favorite statistics for the thumb, this time residual on the same data set. So the same set. Residual thumb, favorite statistics, residuals. Residual. Okay, thumb, I got that one, and residual. Let me see. Residual, thumb, residual. Okay. And coming from data. So here data equals tiny fingers. Residual. Tiny fingers. Oh, this one has the same issue. The last two, see, these two. Q1 56 60. See, this is for the thumb length, this is for the residual. By looking at the mean is 62. See, this one mean, see, E means that 10 to the power of -14. That means it's going to be very, very, very small. That means you have to move this decimal place to the left by how many locations? 14 location to the left. Then you're going to have this, and then keep over here. And you have this kind of a very extremely small value, which is approximately 0. See, like that. Now they say instead of doing for the tiny fingers data, you go ahead and do this one for the full data set, which is called the fingers data. Okay. Now they are looking for everything. This code for the before fits the empty model. Okay. Fit the empty model for thumb, but this time data coming from fingers. Now you're going to find the prediction. How do you find the prediction? You can remember how you find in prediction. It's easy. See, not the residual. See, not the residual. I'm gonna use this one. Easy. Okay. Copy and go to the full data set. And it's called now fingers predict, not the tiny. this one called the empty model simply. And now you generate residual from the empty model. You can generate, you can say res empty model. See? Empty dot, that's the name of that particular object, empty model. And this print us the 10 lines of the fingers. And then we're gonna 10 because we don't have a 6 this time, we have 157. We don't want to predict time that put everything. So we're gonna select fingers, go to that fingers data set, we go to thumb, we predicted and residual and 10 lines. Okay, let's see. Oops. Object residual not found. Okay, let's say what? Empty model receipt. Oh, let's see. What's the problem here? Tiny receipt. Yeah, I'm sorry that even over here that I put it earlier that receipt, it should be receipt. Receipt of the linear model. I had that in the head, but by accident I wrote like that. This should be the right one, okay? Not this one. This one should be taken out. Receipt, okay? So you're gonna put receipt. Then you have thumb, predict, and residual of the 10 individuals. See? Then they have the same thing like here. And then make a histogram for thumb, make a histogram for the predictor, make a histogram for the residual. Okay, we know how to do that. See, it's easy. If you go ahead and get this one, histogram. Okay, doesn't matter. Let's go ahead and say gf underscore histogram. Okay, and it's gonna go to I'm gonna go to definitely x-axis. That's why I wrote that one right after the tilde. See, fingers data this time, fingers. The same thing we can do to. We don't do any fancy one, just a basic histogram. So thumb, we can go to the predicted. Then we're gonna do the same thing for residual. And then run. See, there are 3. That's the last one. Last one for the residual having that 0. See, that's the average is 0. Right before that one, see, that's the predicted one, 61 point something. See, this is symmetric around its average. See, it's clustered. Pretty much all the data clustered around the average of the thumb lens. That's the average. This is the error being centered around this guy. See. Venturing into the world of mathematical notation. Let's go ahead and look at the mathematical notation to talk about that, how to get these symbols. Okay, that earlier I mentioned that one. So I would give you like some kind of a thing I mentioned earlier that mathematical. See, so a little bit, not in large scale, mean mathematical. See, notations. We saw that one earlier. See, we call the data we call y. Model, in this case, in null model, we call y bar. Error or residual is denoted by epsilon. Actually, error is denoted by e, residual, sorry. More specific. If you put residual, you can put epsilon. Okay, residual error. Sorry, error. You put epsilon. Okay, and call it epsilon. It's a Greek letter to indicate the error. Residual. You can put E. See, which is, we know what is this one. This is y bar. And if you write the model, this is how you're going to write the model. See, y equals y bar plus epsilon, or you can say data equals model, null model plus epsilon. See, epsilon, or you can say data null model, null or empty model, okay, plus E, doesn't matter. Anyway, you want to write. So mathematically like that. And we can talk about that y bar, the sample mean, see, sample means or mean of outcome variable. See, that means average of y, average of y. How do you find that one? You denote by y bar. See, y bar. You see, sum of all data values divided by number of what? Number of individuals, or whatever the word you see, number of numbers, or now sample size, number of numbers, number of numbers. That's the same thing. Sum, they're gonna indicate sum of all number of numbers. They're gonna indicate like this way. Y bar, sum of all numbers, sum they denote by something like this. See? Sigma. This is called sigma. Sigma means summation, sum of, or summation. See? Summation. Whose summation? Y. Y indicates a variable divided by n. N means the sample size. That's the same thing about the number of numbers. Number of numbers and sample size are the same. Okay? That's why they put like that. In addition to that one, they say your I, they're gonna put that to indicate the data points. You put the yi. In that way, you can tell that I goes from 1 to n. I goes from 1 to n. I goes from 1 to n. If I write this one very clearly, I goes from 1 to n of yi divided by n is y bar. This means you're going to add y1 plus y2 plus y3 yn divided by n would give you sample mean. See? So when it comes to that, this symbol, this notation, see, yi, if you want, you can put the yi, or simply you can say y bar is nothing but summation. You don't have to worry about the y divided by n. That's it. That's another way of writing. Everybody knows what this means. Summation of y divided by n. Sample size. You don't need this I. But they have used that one. If you want, you can use that one too. Okay? That's why they say, see? The sum of, see? That's the same thing we can express. If it is x bar, any bar can be expressed, see? X bar or y bar doesn't matter. If it is x bar, you have xi. And or sum of, see, y1, y1, 2 divided by n, see? See, there are several ways of writing the same thing. That means when I'm going to write here y bar, yeah, I'm going to write the other side. The mean of y, so you can say y bar, you can write summation okay, summation yi over n, summation yi over n. So many ways, same thing. Okay, I'm writing the same thing in different ways. Sum I goes from 1 to n, or you can simply say summation yi divided by n, or you can say sum y1 comma y2 comma blah 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 yn divided by n. See? So another way of it. Okay. Or equal sign. See, you can express. See, not summation cannot go to the denominator, only to the numerator. Okay, only to the numerator. Numerator means that in a fraction, this top part is the that's the numerator. See, the bottom part is the denominator. Okay. Sum can go to only to numerator only. See that notation. Sum. See, like that. See? There's several ways of writing. If it is x bar, the mean of x. If you have mean of x, the mean of x, then you do the same thing. X bar summation xi, I goes from 1 to n, whole thing divided by n, or without I, you simply say x divided by n, or sum of x1 comma x2 comma dot 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 xn, 3 dots. Continuation is given by 3 dots. Okay, these are called 3 dots or ellipses to indicate the continuation. Continuation. So 3 ellipses. Okay, so you can write like that, or sometime if you want, some people they prefer to write the same thing, and this one we can write 1 over n times. See, 1 over n times summation of y. See, that's the same thing. This one summation 1 over n summation xi. See, was 1 over n summation just simply y, or summation 1 over n summation simply x. See, like 1 over n you can pull out. After dividing, you can simply say 1 over n. See? Several ways. See? This is for x. Several ways of telling that this is for y. See? That's just a notation. It's a simple, very simple, basic notation. Okay, you don't have to worry about that. See, that's what they were talking about here. Then if you use that one with the notation, see, as I mentioned over here, I used that notation earlier too. See, now I'm gonna come and see, little bit add another notation. Okay, see, then I can remember you had the data. Data equals model, null model plus error. See, how do you write this one in mathematics? Y, this is y bar plus e, error, or you can say residual. Okay, residual, thinking this is a sample version. Okay, sample version. Okay, error or residual. See, doesn't matter. See, they use the error, but since we are dealing with the data, okay, it's a residual. See, in a sample, we are dealing with data, but doesn't matter. In a sample, okay, this I'm gonna write this one very clearly for you to see. Okay, in a population, if you have a population, if you have a data and null model, then you have a data, you have a null model equals null model plus error. Okay, error. Okay, error. Okay, how do you write this in mathematical notation? Y equals y bar plus epsilon. See, that's for the population. See, y bar plus. Actually, for the y bar, they are using something like this. Okay, y bar being denoted by mu. See, mu. This is called mu. Mu means population mean. Okay, if I write very clearly. Then you come to the sample. Sample, you do the same thing. You're going to say data equals null model. Mu is another Greek letter to indicate the population mean. It looks like, see, it's that Latin version of mu, the m, okay, plus residual. This time you call the residual. Okay, I make it very clear. Data is again y, but this time null model is denoted by y bar plus e. Right. Okay, that's what they say, to make it very clear. This y bar means nothing but, see, y bar means nothing but sample mean. It's a sample mean. Now whatever the sample. This one is unknown, okay? That's why we are estimating. This is it. This is, see, this is actually this is the real model. This is the model for the population. Since we cannot access the population, we're gonna go ahead and pick this one. This is called estimation. See, estimation or prediction with the aid of the sample. See, so mu in another way, sorry, y bar is an estimate of mu. See, in another way. Okay. And on the other hand, again, I'm going to go back to sample because the sample is the one that I have in my hand. Data, excuse me, null model, null or empty model, plus residual. This one given by y, this one given by y bar, this one given by e. Oh, I'm going to introduce another one for this one. I can say with the y hat plus, see, y hat. This is y bar. Okay, y bar, y bar. Y hat is nothing but y hat is the estimated y or predicted y. In this case, it is equivalent to y bar, which is sample mean. See? Therefore, y hat is the same thing. See? Another way of telling this. See? See? Like that. If you want, you can say the y bar, y hat. I'm sorry, this one capital letters. If you want capital letters, simple letters, this one doesn't matter. See? So y hat is nothing but the estimated value. See? Oh, y bar, the same thing in this model, but down the road in another model, I can call that one y bar, y hat. When we're gonna add more variables. We haven't introduced any variable. We are introducing only. We are working with only one variable. We are using its own mean to make the prediction. Okay, we're gonna utilize mean as a predicted value to do the future prediction as well. Okay. That's what this is. Look at here. Let's represent the student one as data equals model error. Match the numbers. Y. Y for what? First student's number. See, if it is for the first student, thumb length. Y hat what? Model's prediction for the number one student. This is the true value, but the model's gonna predict this one and say it's gonna be the average. Y hat is the predicted value or the average value. E means how different model is from the student's thumb length. Predicted value, how far that predicted value is away from the predicted value, and this one. See, that's called the error. In another way that we can say the error is y minus y bar. See, oh, see, residual. Residual is nothing but see data minus predicted value. You know that. So this is residual is denoted by E is data means y minus y hat, or same as y minus y bar. See? That's what this. See? The difference between the predicted value and the true value. See, true value and the predicted value. See, this is a true value. It's a predicted value or estimated value. Now what are you gonna do? We go further down a little bit and add another notation again. Okay. Then I'm gonna say, okay. Then I'm gonna say again in sample. I'm gonna go to sample again and say my model. This is my empty or null model. Empty or null doesn't matter. Null model plus residual is denoted by y. This is denoted by, I'm gonna denote this by b naught this time. B naught for a certain reason. This B naught is important because the B naught in a, like if you can remember that if you have taken any math class as a straight line, see, y equals mx plus b. You can remember that's the equation of the straight line. This is the slope. This is the intercept. Can you remember? We call the intercept for the in the empty model we have intercept only. That's why we are using b. Okay, we can see the reason why we are using that one, because it has been modeled by a straight line down the road. So here we don't do anything now. So I'm going to call that one B naught plus E. See, that's another way of it. Then the error residual again you can write. Residual is nothing but y minus y hat to y minus B naught to y minus y bar. That's the same thing. See, that's the same thing, which is E. See, that's the same thing. So therefore, your empty model, I'm going to summarize here, empty or null model, see, can be written like model equals empty or null model plus residual, which is y equals, you can say b naught plus c, or y hat plus e, or y bar plus e. Any way you can express. That means you have a first way y equals b naught plus c. That's one way of expressing. Or y equals y hat plus c. Second way of expressing. Third one is null model. Y equals y bar plus c. There are three ways you can write this equation. That's the intercept. This is the intercept. Intercept. See? That's the intercept. Can you remember this? The intercept. Y hat, estimated value. Y bar, average. The same idea. Intercept, estimated value or predicted value. Mean, that's the same. Here we're going to call, see, V naught, intercept. See, intercept. Here, estimated or predicted Y value. Intercept of Y, okay? Intercept of Y, okay? Here, Y bar means sample average of Y. See? Based on whatever the notation you utilize, it has a physical meaning. Physical meaning for that. Meaning for that one. Okay. See, physical meaning for that. See. That's what they were telling here. You can use these 3 years notation. See, that's the same thing they were talking. Again, y means the data, thumb. V naught means the, V naught is the mean. See, same thing. E is the residual. See, then again they're gonna say y is the date, V naught is the prediction. Same thing. See? And see, that's another way to look at it. 3 ways of getting this. See? Now they're going to talk about the statistics and parameter. Look at now. They come to the different thing now, okay? Now what I'm going to do, this is what I'm going to do, okay? To make this one very easy, okay? I'm going to go ahead and show you something, our discussion. We never, I cannot remember, at a certain point, I mentioned that one. I told here, I have 2 types of model structures. I have 2 structures, one structure for the population, one structure for the sample. We were most of the time allocated our time to explain that structure of this one. But definitely your model coming not from the sample, it's coming from the population. It has been structured for the population. If it is a population, how that can be written? Not only this way? No, there are so many ways. There are 3 ways if you can write this one here. In a similar fashion, equivalent to that one, there are 3 ways you can write the same thing in a population as well. Okay, look at in the next page how I'm going to do this one. So I'm going to think you have a population. See, that's the population. From the population, you pick a sample. You know that sample. The sample. I made it larger for me to write. In here, your model is nothing but your data. Again, data equals same thing, null. I'm going to say null only, null plus the error. We call the error. Okay? Error. That same thing I'm going to write y equals, see, null model, you have not y bar, not y hat, you have a mu plus epsilon. See, mu plus epsilon. Or related to B, you can say y is beta naught plus epsilon. Look at mu. This is mu, mean population mean, similar to sample mean. Beta, see this one beta, indicate intercept in population. Population intercept, see population intercept. That means the population intercept of y, okay, the population. And this one is epsilon. Epsilon is the error. In a similar fashion, you write here data equals null model plus residual. We call residual. Then, if you write this one, you can remember you wrote this one in 3 ways. Y equals y hat plus e. You wrote this one y equals y bar related to the first one over here, e. And y equals b naught plus c. Look at, I wrote in 3 ways. See, it's a sample model. It's a population model. See, population model. This is a sample model. That means you can write y equals mu plus epsilon related to this one. See, this is in population. Related to that one in sample, what's its counterpart? You can say y equals y bar plus e. You can write this one in the beta naught plus epsilon, and its counterpart would be b naught plus c. And then you can write this one simply y hat. Sorry, not this one, the other one. I'm sorry, this one. And put these 2 together, you can write. Okay, if I write here, y equals y hat plus c. See, There's a 3 ways you can go. That's what they were telling this one. In that way, you know, y bar is an estimate of mu, b naught in estimate of beta naught. Okay, that's the discussion we have to build up over here. See? So that means, see, y bar is an estimate of mu. B naught is an estimate of beta naught. E is an estimate of epsilon. See? Y equals y bar plus E is an estimate of y equals mu plus epsilon. So y equals b naught plus E is an estimate of y equals beta naught plus epsilon. See? So you can say y equals y hat plus E is an estimate of either y equals mu plus epsilon or y equals beta plus epsilon. That's the idea. See? That's the idea. They are estimate. See, since we cannot access the population, population has the model. Population has the model. With the aid of the model, we're gonna write its counterpart. See. This one, mu. Y hat this one. See, it seems like this one. See, this is gonna go with that. It's gonna go with that. Okay. See, this gonna go with that. This gonna go with that. Okay. This is the sampling process. See. So those are estimate. That's the estimate. This is the population model. Then that one we're gonna use the sample version, notation wise. Okay. But if you go back, you can say y bar is an estimate of mu. B naught is an estimate of beta naught. E is an estimate of epsilon. And y equals y plus E estimate of y equals mu plus epsilon. Y equals B naught plus E is an estimate of y equals beta naught plus epsilon. Beta naught. See? Plus epsilon. Or I'm gonna write this one. See? These letters clearly. This is mu. This is beta naught plus epsilon. See? Oh, this one means y hat. See this one. You can use any of these notation for the sample version. You can use any of these notation for your population version. Okay, that's what they say. See? That's what. If these are coming from population, if I go back to here, in here, anything you find, this one is called the parameters. Parameters. Here they are called statistics. Sample. What are the parameters here? Mu, beta naught, and epsilon. Those are parameters. Mainly we're not going to take this one. Yeah, parameters. See, here what are the see this error. See, this one, if you want, you can neglect that this term. Then here statistics are y bar, v naught, and e. And e I'm going to take out for certain reason. It's a random variable. Okay, because of a random variable. Okay, e I take out. And mainly mu and b, anything coming from parameter, any characteristics of population is called the parameters. Any characteristics of the sample is called the statistics. See? That's why they call statistics and classic. When we use the mean as the model, why do we call it a parameter estimate? See? Because we can't calculate the mean of the population. We must estimate it. We cannot calculate mu. We calculate its estimate, which is y bar. That's what they say. What's the difference between model of data and a model of the DGP? See, model of data, see, both of the above are different. See, model of data and model of GDP means this modeling, the population model and sample model, how they differ. See, they have a difference. See, they have a parameters here, mu unknown. See, and on the other hand, parameters are unknown, 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 and fixed. Statistics are known but varying. Okay, we're gonna talk about that variability later on. They are varying. At least they know. Okay, so parameters are, see, fixed and unknown. Statistics means any characteristics of the sample is called the statistics. They are known. We have already calculated the y bar. V naught and y bar the same thing. Those are known. Okay, or y hat. Okay. Another statistics would be y hat. Y hat, y bar, V naught, all that statistics. Okay. So I'm going to write here very clearly. See, if you go back to here, these are called, see, these are called statistics. These are called mainly parameters. Okay, mainly, except for that. Mainly, I'm going to highlight this one. This guy, this guy, this guy, like that. Okay, and this one as well. See, like that. See? This circle ones are parameters. That's what they say here. See, that's the same thing they were talking about. When we ran the R code to fit the empty model to our data, blah, blah, blah. So that's a statistics. It's a parameter estimate. Statistics is a parameter estimate. Statistics is a parameter estimate. See? Parameter estimate. See? Statistics are the parameter estimates. Statistic is a parameter estimate. Then what are the parameters? Parameters are the some kind of a characteristics of the population. See, characteristics of the population. See, statistic, the characteristic. See, we don't generally know what the true parameter is. See, the mean of the population, an example of parameter. That means any characteristics, any summary of the population are called the parameters. Any summary means like instead of going to individual data in the population, you can talk about the population mean. That's the parameter. You can go to the population standard deviation. You can go to the population median, mode, anything. Those are called parameters. Okay. And in this model, we're going to use even the beta naught, mu. Those are parameters. And the statistics would be anything that's the characteristics or summary of this sample, which are called statistics. Those are, on the other hand, estimate of, see, parameter is an estimate of, statistics is an estimate of parameter. See, when we can use the mean as a model, why do we call it the parameter? Because we cannot calculate the population mean. See, what difference? We calculate the statistics for sure, the parameter estimate. We represent the GLM notation as B naught or B naught for sure. We don't use anything for the sample beta naught, no, B naught. Okay. We run study and calculate the parameter estimate B naught 25. We decide to run the study again and again and parameter estimate of beta naught 25. Based on these two studies, what do we know about the population parameter beta naught? We know that 25 is our best estimate for beta naught, but we can never be sure of true population parameter. We don't know. We can say that estimate would be 25, but we don't know how much this beta naught is, because we don't know. Okay? That's how we estimate. So match the each one. Okay, mean of the population. See, mu. Error around the population model. See, error. See, epsilon. Mean of a sample. Y bar. Error around the sample. E. See? Error or that residual. They call the residual. See, now you're familiar as the which is which. Describe sample. Statistics. Describe population. Parameter. See, V naught and Y bar are the same. See, B naught and beta naught. This is for the sample. This is for the population. B naught and Y bar the same. But B naught and beta naught, B naught for the sample version, this one for the population version. The power of aggregation is the end of the summarizing what we have. Let's say summarize, okay? Now we have a data, okay? We have a population. See, based on the data, we call the data. This one also data. We have a data within the population. Actually, this should be sample rather than they call the data, they call the sample. Okay? Sample is population. See, person's thumb length, sample mean plus error. See, you know that you can write like this, you can write like this, you can write like this, you can write like this. See? Any one parameter model, see, estimate from the data, not just the mean. See? Can be used to represent any one parameter model of the problem, not just the mean. See? It is not just the mean plus the error, error incurred. See? Error, this is a residual. This is the beta node, population intercept, sample intercept, population mean, sample means, same thing. See? So, see, so that's for your convenience. Let's go through this chapter 5 little bit. I'm gonna see, show you these ones and you can get the see what's the observation unit in this data frame. You can see, okay, so see something, some stuff. If you have any question that actually that even that I think this section is not hard, that if you have anything that you want to know that more detail, and then I'm gonna keep that the office hours Wednesday 5:30 to 6:30 or 7:30 from your time, from the Pacific Standard that Pacific Standard or daylight time, okay, which is that it's going to be 5:30 means 8:30 for me to in Eastern time in Chattanooga, Tennessee. So pretty much like the same time that we meet the class, we're going to meet, and then we can discuss, okay, even if no one going to show up, that there's nothing for me to record for sure. But Thursday when we meet, that if anyone, no one gonna show up, that but still I'm gonna go ahead and record. But make sure to that be present, in that way you can build up the discussion listening to this one, because you don't have to go through all the details over here, but if you need more details you can read it. But in order to just do the code, the basics of structure and the summary of this, all the contents can be easily that comprehend if you're going to present over here for this discussion, okay? So I'm gonna wind up over here, and then I'll see you guys either on Wednesday or Thursday for sure. Okay, stay safe and be well. Okay, have a good night. Take care. Bye bye.